chapter 7-9, dealing with negative exponents and zero exponents. And at this stage, we've dealt with multiplying exponents with like bases and dividing. So at this point, we should be relatively strong in all the components, but let's go over these. So these examples that they provide you to begin with is we see that how do we change? We can't simplify a negative exponent. Red's not a good starting color. So if we have 10 to the negative 2, we can't simplify that. So the way that we get rid of the exponent is we move its location. This is currently in the numerator, so we would move the base and the exponent into the denominator, which in turn changes it from a negative exponent to a positive exponent. And we put a 1 in the numerator as a holding place. And now we can simplify that. 10 to the second is 100, and that's a nice way. We look at the next example again. 5 to the negative 3, we can't simplify negative exponents, so we put the base, which is 5, and its exponent, which is 3, in the denominator, and we're changing the sign of the exponent. 5 to the third is 125 in the denominator, and we get 1 over 125. Here's a tricky one that I don't think they give as an example. Nope. What if I have this, 1 over 4 to the negative second? Oh, now we still can't simplify this because we have a negative exponent, but notice where it is. It's in the denominator. So if I'm going to change the sign of this exponent from a negative to a positive, I have to change the location. It's in the denominator. So if I change it, it's going to go to the numerator and become a positive exponent. And we get 16. So that's a nice little trick one that students aren't aware of. And I'll give you one more. There's still one more that we can do. There is a fraction if I have 3/4 to the negative 2. We could think if we change the sign of the exponent from negative to positive, it's going to change the location for each of the items. So the 4 is actually going to go into the numerator, and the 3 is going to go into the denominator. So we take the reciprocal, and taking the reciprocal makes it 4/3 to the second. We change the negative to a positive, and then we distribute it into each of them. So it becomes 4 squared, 3 squared, and it becomes 16 over 9. Cool. So that's the nice, easy trick way, the most efficient way. Now, the other way to do this is to distribute the exponent to each of them first, and then flip. Then that becomes 3 squared, then that becomes 4 squared, and you still get 16 over 9. So this one is distributing first. This one is getting rid of, the top one is getting rid of the negative exponent first. Either way is fine. So this becomes 1 over 3. This becomes 1 over 6. Or we can say 1 over 3 to the 1, which needs to be written. Always make sure that you do that, and you can do this, which equals 1 over 6. 6 to the first is equal to 6. So we're going to change the exponent from negative to positive by putting it in the denominator, and then we get 1 over 64. Remember, 4 to the third is not 4 times 3. It is not going to be 1 over 12. This is 1 over 3 to the fourth, which is equal to 1 over 81. Mr. Mac knows his squares and cubes and to the fourth. 5 to the negative second is equivalent to 1 over 5 to the second, which is equal to 1 over 25. 1 over 7 squared, which is 1/49. We're getting rid of the negative exponent by changing its location. in the start, it's in the numerator. Now we're going to put in the denominator, and that becomes 1 over 32. 1, 2, 3, 4, 5, which is 4. 16 doubled is 32. Yep. 11 to the negative second is 1 over 11 to the second, which is 1 over 121. 9 to the 0. All right, so here's where it starts getting interesting. So if we have 9 to the 4th over 9 to the 4th, remember, as I told you at the beginning of this, we should know our division and multiplication already by heart. We would do 9 to the 4 minus 4, which equals 9 to the 0. And we know that anything over itself in a fraction will equal 1. So that is equal to 1. So this answer is equal to 1. Now, negative 7 to the 0 is much like we say the opposite of 7 to the 0. So 7 to the 0 is equal to 1, and the opposite of that would be negative 1. So here is a little bit of a trick. Something we have to be aware of, that we're always going to do the exponent before the sign. So when we have exponents, we have to do 7 to the 0 and then plop on the negative there. Now this is a little bit different. Don't confuse the negative here and the negative in the other one. This is a negative exponent. This is a negative coefficient. So this is 1 to the negative 3. We can't simplify this because we have to get rid of the negative exponent. So that 1 goes in the denominator. 1 to the 3rd is 1 times 1 times 1, which is 1. And 1 over 1 is equal to 1. Very important. That's a good question. A lot of students get that wrong. They say 1/3, negative 3, whole bunch of wrong answers. The only answer is 1. 5 to the negative 1 is equal to 1 over 5. We put that 5 in the denominator. 1 over 6 to the second, which is 1 over 36. And you should be able to do these this easy. 5 to the 0 equals 1. 10 to the negative 4 is equal to 1 over 10 to the 4. 10 to the 4th is a 1 with 1, 2, 3, 4 zeros. 7 to the negative 3 is 1 over 7 to the 3rd, which equals 7 times 7, which is 49, times 7 is 743. 7 cubed, 343. All right, now these are all the rules that I was talking about. When we multiply like bases, we're going to add their exponents. When we divide like bases, we are going to subtract their exponents. When you have a power of a power, we are going to multiply their exponents. We can distribute the exponent into each of the terms, and we can still distribute it when it's division. So those are the important rules that we should be proficient at. Now, we are dividing like bases. The base is 2. The exponents are 1 and negative 3. So we're going to have 2 to the 1 minus negative 3. We subtract when we divide. So that division is represented there. And we're going to subtract the exponents. The numerator minus the denominator. That negative needs to be represented as its own entity, and the blue subtraction is the act of dividing. So that becomes 1 plus 3, that becomes 2 to the 4th, which equals 16. This is 4 to the negative 2 minus negative 3, which is 4 to the negative 2 plus 3, which is 4 to the first, which is 4. We have to write it as 4. Do not write it as 4 to the 1. Now we are multiplying like bases, so we are going to add their exponents. And that gives us 9. So we have to look and see this is a power of a power. We know that a power of a power, we are going to multiply their exponents. That was the last one that we had seen. Not that one, this one. So we see the power of a power. We are going to multiply their exponents. So this becomes 5 to the negative 2. We have to get rid of that negative exponent by moving the location and making it positive, and then we get 1 over 25. 2 to the negative 1 over 1, technically, I mean, anything over 1 is itself, so 2 to the negative 1 to the second, I'm going to simplify that just because I don't know why they have that. And now we have a power of a power, so it's negative 1 times 2, which is 2 to the negative 2, which is equal to 1 over 2 to the second, which is equal to 1 over 4. Let's simplify inside. So 4 to the third minus negative 2 to the 0. And that's 4 to the 3 plus 2 to the 0. And that's 4 to the 5th to the 0. We have a power of a power, so we have 5 times 0, which is 4 to the 0, which equals 1. We have a power of a power, negative 1 times negative 2, which is 5 to the second, which equals 25. We have a power of a power, so we're going to multiply those exponents. Negative 2 times negative 1 is 2. 3 to the second is 9. We are going to distribute. Remember, we saw that as one of the steps, so we're going to distribute. This is one way of doing it. And then we get, I got to change the exponent of this. So that's going to go in the denominator. And I'm going to change the exponent of this. And that's going to change the location. So that goes in the numerator. And we get 4 over 9. And that looks very similar to the problem that I had done earlier. The other way to do this is you can get rid of the negative exponent first. So we can change it from a positive to a negative exponent by taking the reciprocal. And then we can distribute that out to each of the terms, and we get 4 over 9. Either way is okay. We have division. I'm going to simplify inside. We have 3 to the 4th minus negative 2 to the 0. To the 0. That becomes 3 to the 4 plus 2 to the 0. And this becomes 3 to the 6th to the 0. Power of a power, we're going to multiply those exponents. And we get 3 to the 0, which equals 1. Ooh, this is such a good one. I'm going to look at this as a vinculum. Well, I'm going to look at it as division. And also because there are multiple operations going on. And then I'm also going to look at that multiplication. So if I look at the first part, 5 to the negative 2 times 5 to the first, well, I would write that as we have like bases and we're multiplying, so I'm going to add those exponents. And then I'm going to divide, which is actually the subtraction of that. Because they're like bases, because I have like bases for all 3 terms, I'm going to take this. Oh, I don't want the green. I've already used green. I want blue. So I have this negative 2. And because it's multiplication, I'm going to add those. And then I'm going to add it to 1. And then I have, oh, I shouldn't have used that because this is going to be my division to this term. Whoa. To that term. So, makes sense? Hopefully it does. And now we can simplify it. So this is 5 to the negative 2 plus 1 plus 1. And this is 5 to the negative 2, well, negative 1 plus 1, which is 5 to the 0, which equals 1. All that equals 1? What? That's so silly. Let's do this one. We have like bases. All three of our terms have like bases. 3 is the base. So we're multiplying these exponents, so we'd add those, and then we would subtract that one because we're dividing. So it'll look like 3 to the negative 4 plus 2 minus negative 2. Negative 4 plus 2 plus 2, which again equals 3 to the negative 2 plus 2, 3 to the 0, which equals 1. Blah. Oh, this is a good one. So this can be seen as this. If you understand it in this manner, and we know that we have to deal with this negative exponent, and that's the only thing that's going to be affected by this negative exponent, that coefficient 2 is separate from it. So the 2 stays there, and it's just the x to the second that needs to be moved. And then this is our answer. So this is a common mistake. The mistake, the wrong answer, is 1 over 2x squared. That's the wrong answer. Don't move the coefficient. Coefficient is separate to the variable. And we see it again. So the 3 is going to stay, and it's x to the negative 3 that only moves down. The exponent is negative 3, and the base of that exponent is only the x, because we need to be able to see this as 3 times x to the negative 3. This is the quantity. So if we're going to change, there's two ways we can do this. We can distribute it out to both. So you get 2 to the negative 2 and x to the negative 2, which would equal 1 over 2 to the second times 1 over x to the second, which would equal 1 over 4x squared. That's one way of looking at that problem. The other way is we have the quantity of 2x to the negative 2. I can get rid of that negative by moving it in the denominator, and then I'm going to distribute out. So I get 1 over 2 to the second times x to the second, which equals 1 over 4x to the second. Both the same answer. The quantity again, I'm going to do it in this fashion this time. I'm going to distribute that cube out, so we'll get 3 cubed x cubed. 3 cubed is 27, x to the third is the good answer. Give your answers using positive exponents. So remember, I would look at this, and so I would write this as this, and that answer would be y in the numerator, x squared in the denominator. That's the only thing that has to move. Same thing here. I'd write this, I'd look at this in that manner, and we'd move the a to the negative 2 into the denominator. B to the third stays in the numerator, so we get b to the third over a squared. We have like bases that we're multiplying, so we're going to add their exponents. That's simplified. We have like bases and we're multiplying, so we're going to add their exponents, which gives us negative 1. We have to only have positive exponents. Notice there is not, nope, wrong. The wrong answer is 1 over n to the first. That is wrong. We don't write n to the first. We're going to distribute. We have a power of a power, so we are going to multiply those exponents. That becomes m to the negative 6, and that becomes 1 over m to the 6th. We have a power of a power. We're going to multiply their exponents. x to the negative 6 is 1 over x to the 6. Ah, this is a good one. So we can do a couple things. I'm going to do, let's get rid of that negative exponent before we do anything. And now let's distribute to each of the terms. And we get 2 squared over x to the second times 2. Power of a power. So we get 4 over x to the fourth is going to be our final answer. Now, the other way we could have done this is 2x to the negative second to the second. We can distribute. So we could have just distributed. We could have distributed this 2 into each of the terms. And that gives us 2 to the second times x to the negative 2 times 2, which is 4 times x to the negative 4. And that becomes 4 over x to the fourth, because no negative exponents, using only positive exponents. Let's distribute 3 to the second times x to the negative 1 times 2, which is 9 times x to the negative 2, which is 9 over x to the second. We are dividing like bases, so we are going to subtract their exponents. This is y to the 2 plus 3, or y to the fifth. So you notice each time I'm looking, am I multiplying? Am I dividing? Do I have a power of a power? Those are the 3 skills that we're working on in this chapter. We are dividing, so we are going to subtract their exponents. You get u to the negative 10, which equals 1 over u to the 10th. That's a horrible 10. We are dividing. Let's subtract their exponents. That makes negative 8, which makes 1 over c to the 8th. We are dividing. Let's subtract. That is d to the 3 plus 3, or d to the 6th. These don't cancel because they are opposite. They only would cancel if they were identical numerator and denominator. X to the negative 4 minus negative 2. We are subtracting negative 4 plus 2, which is x to the negative 2, which is 1 over x to the second. Good. I think you're good. We are dividing like bases. We're going to subtract their exponents. We get m to the negative 6 plus 8. We get m squared. Hey, we're done. Nice. Love it. Oh, sorry. All right. Good luck. Hopefully that helps. Get a good study on.